Hi, this is Miss Smith with Enrichology Tutoring, bringing you a quick video going over some common mistakes I see students do when they're working with solving for a variable in an equation. So I'm gonna go over those top three mistakes that I see them do right after. Well, like now. Mistake number one: forgetting to distribute a negative sign. So negative right here, this -3 is going to be multiplied by both the x and the -4. What I'll often see students do is they'll do this -3 times x, so it'll be -3x minus 4 equals 12, and then they'll continue to solve this from here, and all the rest of their logic may be correct. However, they'll end up getting right here, and they have this -3x equals 16, and then they have to divide by -3, divide by -3, and of course they get x is equal to 16 over -3 or -16 over 3. So this, however, is incorrect. Why? They went wrong right here. This -3 is being multiplied by both of these terms. So when we solve this, we have to do some things a little bit different. Everybody is going to get multiplied by a -3, as I said. It's almost like a giveaway. When this -3 is going to be given away to the x and given away to the -4. So this is the correct way to evaluate this equation. Goodness gracious, all these e's. So I'm going to take my -3x and I'm going to multiply it, or my -3 multiplied by x, and I'm going to take my -3 and multiply it by -4. So I end up with -3x plus 12 is equal to 12. Now I'm going to go ahead and move my 12 over, and I'm also going to get into something else. This is another thing that some students sometimes make a mistake with. I'll talk about it in just a moment. But I'm going to move over this 12, and I have to move it over by doing its opposite operation. So if it's being added or addition is occurring over here, I'm going to do subtraction to cancel it out on this side. So I have 12 minus 12. That's also going to cancel out, and I'm going to end up with 0. -3x divided by -3 divided by -3 doesn't really matter because 0 divided by anything is, of course, 0. X, therefore, is equal to 0. Mistake number two: combining unlike terms or incorrectly combining like terms. So with this, we have 5y or 5 times y plus 3 minus 2 times y is equal to 4 times y plus 9. Over here, sometimes I'll see students be like, okay, they have the 5y and the -2y. They may even put 3y and do that correctly, but then they'll add this 3 to that, and they'll be like, oh, that's 6y. No, that's not 6y. This 3 and this 3y are saying two different things. You can think of them almost as speaking two different languages. Don't combine them. You can't combine them unless you're doing, you end up, well, separating this constant away from this variable. That's the only way you can end up doing that. And that's, of course, division at the end. Instead, this is what you would do. The correct way to solve this would be first to combine like terms on the same side. I have 5y and I have a -2y. I'm going to underline both of these so I know that they're the same term, they're speaking the same language. So this is 3y. And then I have plus 3 is equal to 4y plus 9. Now, since this is on one side and these are on the other, I'm going to combine like terms onto their own respective sides. Because I like having my variable on my left-hand side at the end, I'm going to move this 4y over here with this 3y. So in order to do that, I can't cross this barrier or this wall unless I do something dramatic. If this is 4y and this term is positive, I can move it over by making it a negative. And I'm going to subtract 4y. So now that cancels out, and I'm left with a -1y plus 3 equals 9. I need to still combine some more like terms. This 3 and this 9 are both constants. So I can move this 3 over to be with the 9. That's what I'm going to do. But since it's a positive 3, what's the opposite of addition of a 3? Subtraction of a 3. So I'm going to -3 over here and over here. These cancel out, and I'm left with -1y is equal to 6. Now I'm finally left at this last step. where I have -1 times y is equal to 6. What's the opposite of multiplication? Division. So I'm going to divide out this -1. That leaves my y isolated, and I have effectively solved for my variable. Y is equal to -6. The third and final thing I often see learners do is dividing an expression, but only in part. So this example right here, I have 2a plus 6 divided by 4 equals 5. I often see this 2a divided by 4 plus 6 equals 5. And then they've made this into a whole nother expression. This is just 2 times a divided by 4. This is 2 times a plus 6 divided by 4. So here you'll end up with a very different outcome than if you had truly evaluated this whole system. Okay. Just for effect. And then divided by 1/2, divided by 1/2. And I'm going to be left with a being equal to -2. Now, how you correctly evaluate this equation, I'll show you. Now I'm going to show you how to correctly evaluate this equation. So I'm going to take my 2a plus 6 and I'm going to keep it all together over 4 and equal to 5. I want this 4 to be moved over here with the 5. For one, it's a constant. So, hey, even better. The opposite of division is multiplication. So I'm going to multiply 4 out of my denominator. Bam, bam. And I'm left with 2a plus 6 equals 20. And now I have, of course, I'm going to put my wall up so I remember to do the opposite function. I could have did that up here, but I digress. I'm going to move my positive or positive 6 or my subtraction of 6 over by, or addition of 6 by subtracting it. And I am left with 14. 2a. So this is 2 times a. The opposite of multiplication is, of course, division. So I'm going to divide by 2 on both sides, and I get a is equal to 7. Very different outcome than if I had went the other way, where I was incorrectly only dividing it by one term in that expression. So that was my video going over 3 common mistakes that I see students do when they're working on evaluating an equation to solve for a variable. If you enjoyed the video, please like and subscribe to the channel. And as always, thank you for viewing and peace out.